final question on the table is the chi-squared test. Is that you don't have to do the full test, they've done some of the work for you. Important things to read in here, there's 125 plants, that's going to be our total. And then this is our observed data. And then he's done it's expected here, so most of that's already worked out for us. And plus, they've also started to work out the chi-squared, so they've given us the value for the 7 that he's calculated, so that's not the whole thing. And we've got to state our hypothesis, conclusion, everything clearly. Right, so chi-squared with a two-way table. H0 is always there is no association between, and the two things that we're testing, treatment of plants and their survival. Okay, and then so H1 is there is an association, and then you go on to say between people's plants and their survival. Okay, so here we work out the expected by assuming no association, so that is our null hypothesis. Okay, we've got two expected values missing. So remember, for our expected values, it's the row total times the column total divided by the grand total. So if I work out my row total and my column totals that I need, then I can work out my missing values here. So I've got this one is going to be 56 times 30 over 125, and this one here is going to be 56 times 55 over 125, and I can fill those in, use the same accuracy they've got in the table there. So that's 2 decimal places. Okay, and then that's all filled in now. Now they'd already done the sum of the observed minus the expected squared over expected for the 7 values they've given us. So our chi-squared test statistic is the number they've given us plus the other 2 values. So 15 minus 13.44 squared over the expected plus the other one. Okay, and if we work that out, we get 11.5 to 3 significant figures. Okay, once we've done that, we're going to need a value to compare it to, a critical value. So our degrees of freedom, remember this is number of rows minus 1 times number of columns minus 1. So I've got 3 rows and 3 columns, which gives me 2 times 2, so our degrees of freedom is 4. Then using your calculator or the tables in the formula book, you can look up the critical value, which is 11.14. So now I'm going to compare my test, which was 11.5, with my critical value, which is 11.14. So my test statistic is greater than my critical value. So that means it's significant. It would be in the critical region. Remember, a chi-square looks a little bit like this. So if this is my critical value, my test statistic is unlikely. It's in the tail. So we would therefore reject H0 as it's significant. So there is evidence of an association, and then put it in context, association between, and then what we're doing, treatment of plants and their survival.